So the third expression for Cp minus Cv is equal to minus T del V del P at constant T into del P del T at constant V its square. Okay. So now we'll show that Cp minus Cv is equal to this. So to do that, again we'll start follow the same process. Okay, we'll start with entropy as being a function of two variables S and T and V, and then finally we'll arrive at this relation. Okay, Cp minus Cv equals to T del P del T constant V into del V del T constant P. Okay, so again we'll follow the same process. Okay, so I'm not going through the process. Okay, it is just like the second expression. It is the third expression, right? So we started the second expression also in the following way. Okay, we did the same processes, same steps. Then finally we arrived at this equation, which is Cp minus Cv equals to T into del P del T at constant V into del V del T at constant P, which is the the first expression, right? Using this first expression we arrive at the second equation, and then again using the first expression for Cp minus Cv we will find the third expression. So here we will again say that if there is a function f of pressure, volume and temperature which is equals to 0, then we have, again we'll use the relation, the second relation that is stated at the beginning, the second relation of partial differentiation, which is if f p v t equals to 0, then we have del p del v at constant t into cyclically it will go to the del b del t at constant p into del t del p at constant v equals to minus 1. Okay, so now here we'll find the value of this del v del t at constant p. Okay, we'll find the value of del v del t and constant p. Therefore del v del t at constant p will be equals to, we will take these two terms on the right hand side. Okay, so they will come as their reciprocals. So we have this minus sign 1 by this first term del p del v at constant t into reciprocal of this term, which is 1 by del t del p at constant v. Okay, so we have del v del t at constant p on the left hand side equal to minus, so here is the minus 1 by this term del p del v at constant t into 1 by this term del t del p at constant v. Okay, so now what we'll use? So again we'll use the first relation of the partial differentiation, which is the left hand side will have del v del t at constant p equals to minus, so the first term will become del p del t at constant v into the second term will be del v del p at constant t. So which relation we have used here? Since we can say that del x del y at constant z is equal to 1 by del x, del y del x at constant z. Okay, we have used this relation. Okay, so now we'll replace this value of del v del t at constant p in the equation 1. Okay, so now we'll write using this value of del v del t at constant p in equation 1. What we'll have? We'll have on the left hand side we have Cp minus Cv equal to so we have T, the first term, del P del T constant V will be same, then second bracket will replace del V del T at constant P by this expression. So we have minus del P del T at constant V into del V del P at constant T. Okay. Therefore, Cp minus Cv equals to, so there is a minus T. Now you see there are two del P del T. So it will become square. So del P del T square at constant V into del V del P at constant T. Okay. So this is the third expression for Cp minus Cv. Okay. So if we have to find if we are asked to show that Cp the first expression, which is Cp minus Cv equals to T into del P del T into del V del T at constant P, it is the first expression. You will start from here. Okay, you will show all this step and then proved. Okay. Then again, if you have to show the second, you have to prove the second expression. Then again, you will start from here. Okay, right. You will go up to this Cp minus Cv equals to T into del P del T. You have to show all this step. Okay, you will arrive this expression. Then you will do this thing for the second one. Okay, and arrive at this is the second expression. Okay. Then again, if you have to ask to prove this, the third expression, then again you will start it is being function of T and V like this. You will show all this step. Okay, arrived at this equation. Then you will go like this, f p v t equals to this, and then finally you will prove this equation. Okay.